Good evening. You're welcome to today's tutorials from Etandi the Schoolboy. Today we take a look at physics and we continue from where we stopped in measurement and units. Measurement and unit. In our last physics class, we introduced measurement and units. We defined measurements and we also defined what units. And we came down to quantities. We linked quantities, measurement and their units. And we came down to derived quantities and fundamental quantities. And having discussed fundamental quantities, we spend more time on discussing the derived quantities, where we mentioned a particular quantity and we went through how the quantity and the units can be derived. And we also went down to dimension. We didn't just stop at that. We talked about dimension. So we'll start from where we stopped in that class, and we still talk of units. So I want us to conclude units. The units, and the unit used in physics is based on what? Metric system. The unit used currently is based on metric system, where we have what is called base units. We call what is called what? Base units. And the base unit has multiples and submultiples. Look at what I mean. You know about place values of numbers, right? Tens, unit, tens, hundreds, right? Thousand. And are you also familiar with the one below unit? Unit, tenth, hundred. Are you familiar with that one? Where we have, if this is unit, if this is unit, you have 100. No, sorry. We have 10 above unit. We have 10. Next one is what? 1,000. Then below unit you have tenths. You're familiar with it, right? We have, above 10 we have 100. Sorry, above 10 you have 100, and above 100 we have what? 1,000. Let's stop here. Then below unit you have tenths. You have hundreds. Then we have thousands. And in TH, with TH. These are the place values. Now, but are you aware that these place values also has a link with of course, you talk of place value, you talk of decimals, right? Decimal and the dinaries, not just decimals and what? Dinars. So they have a lot to do with decimal system, because here now you have where unit is what? Is what? 1, right? Here 10 is what? Right? This is 100, right? You write what? 100. This is 1,000. You have 1. How many zeros? 3. Here, what are these places? 10 is what? Good, 0.1. 100 is what? 0. What? 0.1. 1,000 is what? 0.001. We have others, so tens of thousand, millions below, millions down, up. You see have tens of thousand, million, billion, up. All those ones are there. But I want to stop at this point. Now, are you aware that this can be changed from this form to the index form? or to this, let's say, index form. Are you aware? Power. Are you aware? And this is the one is 10 raised to the power what? From what you learned in the laws of indices. One is 10 raised to the power what? One is 10 raised to the power what? 0. Good. 0. Good. I like that. One is 10 raised to the power 0. So that means this unit is certain as saying 10 raised to the power what? 0, right? Why 10 is 10 raised to the power what? Please come closer, please. Come closer. Increase your voice, please. 1. Good. 100 is 10 raised to the power what? 10 raised to the power 2, right? 1,000 is what? 10 raised to the power what? 3. Good. 10 is what? 10 raised to the power what? Minus what? 1. 100 is what? 10 raised to the power what? Minus 2. Are you following? Minus what? 2. 1,000 is what? 10 raised to the power what? Minus 1,000. 10 raised to the power what? Minus 3. Now, we are getting to somewhere. These things you are seeing here, are what is called prefixes. These prefixes are what they will add to the base what? Units. We are talking about how metric units are derived. Am I communicating? These things you are seeing here, 10 raised to the power 3, which we derive from place values. 10 raised to the power 2 down to 10 raised to the power 1, 10 raised to the power 0, then 10 raised to the power minus 1, 10 raised to the power minus 2, and the 10 raised to the power minus 3. These things are what we call what? Prefixes. We call them what? Prefixes. Now, the one above this unit is called, the one above unit is called multiples. Am I communicating? The one above the units, this one above here. As I said, that all these things here are called what? Prefixes. The one above this unit, this 34 are called what? Multiples, right? Am I communicating? The one above are called what? Multiples. The one above this thing are called what? Let me write it out. Multiples. While the one below this unit are called what? All of them are prefixes. The one above this this level, are called what? Multiples. The one below this are called sub what? Multiples. So the prefixes are divided into two. The one above 10 raised to the power 0 are called what? Multiples. The one below 10 raised to the power 0 are called what? The negative ones are called what? The one that with negative in the powers are called what? Submultiples. They are units. I want to tell you how these units are used. And this unit, they have their name. This unit you are seeing here, they have their name. I'll give you their names now. I'll give you the names of this unit now. These prefixes, the name they are called. Now, this one here, that is this 10 raised to the power 3. This 10 raised to the power 3 is called kilo. You know it's a prefix. In English language, if you write a prefix, you put what? Dash. Are you aware? Because something needs to be there to complete it. Are you aware? Now, this 10 raised to the power 3 is called kilo. Kilo. I told you that we have 10 raised to the power 4, 10 raised to the power 5, they are above, but let's stop at this level. This 10 raised to the power 3 is called what? Kilo. Then this 10 raised to the power 2, we have 10 raised to the power 2, 10 raised to the power 1. This 10 raised to the power 2 is called what? Are you aware? Are you aware? Huh? Deci. Okay. This one is called kilo. 10 raised to the power 2 is called what? Hecto. Hello? Am I communicating? Hecto. The one following it is called what? Deca. This 10 raised to the power 1 is called what? Deca. Kilo. Hecto. Deca. Then 10 raised to the power minus 1 is called what? Deci. deci is 3 raised to the power minus 1. 3 raised to the power minus 2 is called centi. Good. Centi. Then 3 raised to the power minus 3 is called what? See something. Guess. See it. Say that in your mind. Say it. Milli. 3 raised to the power minus 3 is called what? Milli. I told you there are other ones. I want to stop here. These things are called prefixes. Their name are this. You remember where they are derived from where? Place value. This is what? Place what? Value. Am I communicating? Then their numbers and the prefixes. These are their names. The names of those what? Prefixes. The one above 10.0 is called what? 3.0 is called what? Above is called what? Multiple. Below is called what? Submultiples. Now, here, remember we are talking about units. Here, this is 3 raised to the power minus 1, deci. Now, the base unit is the name of the unit we are working on. And that base unit has prefix of 3 raised to the power 0, which is 1. So if you put it is accepted as the same what? Name. Something like, let's pick a unit for length. The base unit for length is what? Meter. I want to list some base units we have. For length, the base unit is what? Meter. For mass, the base unit is what? Is gram, not kilogram. Is what? Gram. Then for time, the base unit is what? Seconds. Watch now. See how we fit in all this to these prefixes. I told you that the base unit assume the what? The prefix of 3 raised to the power what? 0. Am I communicating? The base unit, are you following me? The base unit assume the prefix of what? 3 raised to the power what? 0, which means it's 1. Nothing is added. Am I communicating? It's just 1. It has no prefix. That's the meaning. Because 3 raised to the power 0 is what? 1. So no prefix. Now, that means what it implies that the base unit should be here. Meter should be here. Let's assume we are working with meter now. Meter should be what? Let's assume we are working with what? Length, right? Are we together? That means meter should be here, right? Because here should be what? The base unit, all right? Am I communicating? The base what? Unit. So here should be what? Meter. Now let's start adding the prefixes. If you add 3 raised to the power 3 to meter, kilo, if you add kilo and meter, you get what? Kilometer. That's where they got that name. Kilo what? Meter. What does this mean? It means that kilometer is 3 raised to the power 3 what? Meter. True of us? Multiply this prefix by the meter. 3 raised to the power, it becomes 3 raised to the power 3 what? Meter. Are we together? Now, then add the prefix, add meter to the prefix hecto. You have what? You have what? Louder, please. Hectometer. Hecto what? Meter. That means hectometer in value is what? 3 raised to the power what? 2 what? Meter. Now, let's look at deca. Put meter to deca. You get what? Deca what? Meter. And decameter is now what? 10 raised to the power 1 meter. That is 10 times 1 meter. 10 times meter, right? 10 meters. So 1 decameter is set as what? 10 meters. Now, this is base unit. Let's go to, this is the one above are called what? Multiples. Let's go down to what? Some multiples. Now, put meter to deci. You get what? Deci what? Meter. That means decimeter is what? 10 raised to the power minus 1 what? Meter. Which means 0.1 meter. Then how many decimeter make 1 meter? 0.1 decimeter make 1 meter. Sorry. Yes, 0.1 decimeter make 1 meter. How many meter? How many how many meter make 1 decimeter? Sorry, I mean 0.1 meter. 0.1 decimeter make what? 1 meter. See what I mean? If here now, if 1 decimeter is 10 raised to the power minus 1 what? Meter. 1 meter is how many decimeter? You divide both sides by what? 10 raised to the power minus 1, right? And get what? 10, right? This will come up, right? 10. That means 1 meter is 10 what? Decimeter. Turn your exercise book. Check meter and decimeter. Is it there? Check meter and decimeter. Is it in your own? So that means 1 meter is equal to 10 what? Decimeter. 10 decimeter make 1 meter. True of us? That is what it is. Now let's go to what? Centimeter. Now add meter to this centi. What will you get? Centi. At least you are familiar with this one, right? How many centimeter make 1 meter? How many centimeter make 1 meter? How many centimeter make 1 meter? Okay, don't worry. We'll do the calculation. Let's just add meter here. If you add meter here now, you get what? You get what? Centimeter, right? Which means 10 raised to the power what? Minus 2 what? Meter. So 1 centimeter is 10 raised to the power minus 2 meter. So if 1 centimeter is 10 raised to the power minus 2 meter, how many centimeter can we find in 1 meter? Are you serious? If 1 centimeter make 0.1 decimeter, 0.1 meter, how many centimeter can you find in 1 meter? Huh? 100. There are 100 centimeter in what? 1 meter. Yes. These things we are learning will also help you in conversions. Please take it seriously. Now then add meter to milli. You get what? Milli what? Millimeter, which is 3 raised to the power what? Minus 3 what? Meter. So how many millimeter make 1 meter? How many meter make 1 millimeter? How many meter make 1 millimeter? Look at this picture and which is 1,000. How many millimeter make 1 meter? What are you doing? Look at the board and tell me the answer. What are you pressing? Look at the board here and tell me the answer. How many millimeter make 1 meter? So, okay, now let me ask it again. Look at the board now and tell me how many meter make 1 millimeter. Let's start from there. Look at the board. How many meter make 1 millimeter? Hey, this is serious. Can you sit well? Look at that board and tell me how many meter make 1 millimeter from the board. 100. Where do you get 100 from? Huh? From this scenario, I wrote how many meter make 1 millimeter? You get up, go to that board. Use your logical mind and look at this thing on the board. Tell me how many meter are in 1 millimeter. Huh? 1,000 millimeter are in 1 meter. 1,000 meter are in 1 millimeter.
0.0
What?
0.0.
0.1. Write on the board. Let me know what you're saying. Where did you get this thing from? From where? What are you solving on the board? Let me even know whether you even know what you are solving. What are you finding now?
You said how many millimeter I want?
That's what I said. How many meter I 1 millimeter?
How many millimeter?
Yes, I 1 millimeter.
3.
3 millimeter and 1 meter. Look at this board and answer my question. What are you looking at? That means you could not even understand what I have been doing here. I mean, you've been nodding your head that you understand what I'm saying. That you understand what I've been saying. 1,000 what? 10,000. Where did you get 10,000 from? Huh? Hey, give me a marker. Go and sit down. That means I'll start from the beginning now. I was here wasting my time. I thought people are following. I thought if you don't answer anything, ask question. Don't keep quiet and be nodding your head for what you don't even understand. It doesn't make sense to me. Yeah? I've been saying that in this class. Once something is mentioned, you don't understand it. Ask question immediately. Don't wait. Don't wait until you ask question before you start. Look at this thing. Okay, let me start from. What did I say about this place? What is this? Huh? Then what is this? Huh? Good. Here, come. The index form. What does have here? Huh? The multiples. Here, come. Below here, come. So multiples. Now, where I carry this thing now and placed here. What do I say about this place? Here. Base unit, not basic unit. Okay, let me start again, please. It makes me unhappy anytime I'm teaching, and once you miss a step, don't wait. Ask question immediately. This is a very important. This is where most students have issues with this unit. Even in the university level, they keep having these issues because they didn't have this foundation. That's what I'm trying to teach people now. But it's disappointing that I will be talking, you keep quiet, you won't ask question. I ask you simple question here. The answer here is here looking at you couldn't say it. Huh? Okay. Please listen carefully, please. Please call my attention if I take any step you don't understand. If I take any step you don't understand, call my attention. If you don't call my attention and I ask questions based on what you are seeing on the board, you don't answer, I will send you out of this class. Once I miss it, I take a step, you don't understand it, ask questions immediately, I will explain it. Don't keep quiet. Now, let's go back here. Fine, what people said here is correct. But when we now came here, I said something. I said that this thing you are seeing here are the prefixes. They are called what? Prefixes. That they attach in the beginning of base units to form a unit. Multiples of the units and the submultiples, depending on what you want to measure. Now, I said that I pointed out three base units here. Base unit for mass, base unit for length, and base unit for what? Time. I told you that of mass is what? Can you see the board? Is what? Gram. That of length is what? Meter. This thing I'm teaching is metric system. of measurement. I'm teaching you now. Remember, we are treating physics, what? Measurement and what? Units. Now, we are telling the unit of this measurement. Now, for mass, the base unit is what? Gram. For length, the base unit is what? Meter. For time, the base unit is what? Seconds. Haven't you heard something like milligram, kilogram, decagram, milligram, kilogram, decagram, decigram, all those things? These things, mega, kilo, milli, they are all prefixes attached to the base unit, which is what? Gram. Split this thing into two now. Kilo will be here. Meter will be here. For what? Length. And I started with length. I told you that kilometer, kilo. I listed the name of these prefixes. Their names are 3 is what? Kilo. Am I communicating? The base unit, the name for 3 is what? Hecto. The name for 1 is what? Deca. They are prefixes, but I'm calling their names now. They have moved from this place value, push it to what? Prefixes in standard form and name them. Kilo, hecto. 1 is what? Deca. 0. I told you that this 0 because 0 is 1. If you multiply it by the base unit or attach it to the base unit, it will 1 is 1, which is what? Unity. There's nothing. It will add any prefix, any name to the what? Base unit. That's why I say, okay, for length, meter is what? There. Because 1 times meter is still what? Meter. Or 1 added to meter is what? Meter, as case may be. But the main operation there is multiplication. Because this 1 times meter will give you what? Meter. Then when I now say, okay, with this, now let me now go back and form the full name of units. Now, I told you here, 3 is kilo. This kilo now, multiply kilo. This thing here, when you bring kilo and meter together, you form what? Kilometer. That means what the meaning of this is what? 3 times what? 1 meter. Are we together? You give you what? 3 what? Meter. See it here. So that means 1 kilometer. 1 kilometer is equal to what? 3 meter. Which is 1,000 watts. Is that not what people have been doing since? 1 kilometer is 1,000 meters. It's not true. 1,000 is not 3 watt. It's not 3 watt. So that means 1 kilometer is what? 1,000 watt meter. That's the real meaning of this kilometer. Now let's move to the next prefix. Next prefix is hecto. And the value is 3 what? 2. Now, if you bring hecto and meter together, it will form what? Hectometer. Hectometer, which is 3 which is hecto, times 1 what? Meter, which is 3 what? Meter. So 1 hectometer. 1 hectometer is what? 100. Good. 3 meter or what? 100 what? Meter. Is it clear? Is it clear? Is it clear? Is it clear? Now, next one is what? Deca. Next one is what? Deca. I told you that deca is if you bring deca and meter together, it will form what? Decameter. Now, but the value of deca is 3 what? 1. So 3 1 times 1 meter is what? 3 1 meter. That means 1 decameter. 1 decameter is how many meter? 1 decameter is 3 1 meter, which is certain as what? 10 meter. 21 meter. Who say meter now? It does you now. Now, are you following me? Good. Now, But if you come down to the base, to here, if you come down to 10 raised to power 0, watch now. If you come down to 10 raised to power 0, this 10 raised to power 0 has no prefix, no name. Now, but if you say 10 raised to power 0 times meter, is that not saying 1 times what? Meter, which is 1 meter. So the unit of the base unit is what? 1 what? Meter. Leave it at that. We are done with multiple. Let's go down to what? Submultiples. Now, deci. I told you that deci is what? 10 raised to power minus 1. No, basically, deci is what? Deci is 10 raised to power minus what? 1. Are we together? Deci is what? 10 raised to power minus what? 1. Now, bring deci and meter together. You form what? Decimeter. Decimeter. What it implies that multiply this value of deci times value of meter. You get what? 10 raised to power minus 2 times what? 1 what? Meter, right? 10 raised to power 2 times 1 meter is what? Sorry, forgive me. Thank you. That means you are following. Take it. Good. 10 raised to power what? And it seems I've been saying 10 raised to power 2 here since. You see, since I've been saying that here. So deci is what? 10 raised to power what? Minus 1, not minus 2. Now, if you multiply 10 raised to power minus 1 times 1 meter, you get what? 10 raised to power minus 1 meter. That means 1 decimeter. 1 decimeter is what? 10 raised to power minus 1 what? Meter, which is certain as saying what? 0.1 what? Meter. Are we together? Now, let me go back to the question I asked you ever since. Now, if 1 decimeter is 0.1 meter, how many meter? How many decimeter will be in 1 meter? If 1 decimeter is 0.1 meter, how many decimeter will be in 1 meter? Don't write anything on that book. Look at it and tell me the answer. If 1 decimeter is 0.1 meter, how many decimeter will be in 1 meter? No idea. Good. Divide both sides by what? By what? 0.1. Here it becomes what? 10 what? 10 what? Deci what? Meter. And here is what? Decimeter is dm, hope you know. Decimeter is dm, hope you know. Hope you know. That's where they got the dm cube we have been using in volume, all this one. Decimeter cube, that's where they got it from. The dm cube we have been using since yesterday. This is where they got it from, decimeter. Decimeter times decimeter times so decimeter, you form what? dm cube. That's why it's a measure of what? Volume. Okay. Ask. What? You came late now, so the time lesson is 4 p.m. You're not by 4:30. Why would you understand? I say 4. I don't play with time. Ask a question. No, don't worry. Ask a question.
So you say that this kilometer is per train.
Yes.
So when 1 meter times that train, that is equals to 1,000. Sorry, so if 2 times that there is the power 2 meter times that 10 is power 3. Okay.
It becomes those ones have was issue, sir. You can simply that one become 2,000 meters now. So that one was issue.
Okay, what about this? Like this one here explain like this those one name raise the power.
Okay. That's where I am now.
You say that
No, you have to write it. It is confused. You don't write when somebody. I just intentionally allow you to write because I know you say ask question, and truly you ask question. You don't write when explanation is going on. It's a very wrong thing to do. Okay, target the right time to do what? Write. Once your lecturer is explaining something, listen first. Then after you write, that's how to do it. Now I said the same pattern we use here. The same pattern we use in multiples. We are using the same pattern in what? Submultiples. Are we together? I say that deci means deci. You know is 10 raised to the power what? Minus what? 1. True of us. Deci is what? Deci is what? Minus 1. Good. If deci is 10 raised to the power minus 1, now get deci, now bring deci and meter together. You form what? Decimeter, right? Now let's multiply their value. 10 raised to the power minus 1 times the value of the deci times 1 meter, which is the unit of the word base unit. It's not true. It becomes what? 0.34 minus 1 what? The same thing we have been doing here since now. Do it again here.
Okay, 1 times 10 raised to the power minus
1 meter, please.
Okay, 1 meter times 10 raised to the power minus
1.
1.
It
What was that then?
will form 10 raised to the power minus 1 meters. So that means 1 decimeter is what? 10 raised to the power minus 1 what? Meters. The same way, 1 kilometer is equal to 10 raised to the power 3 meters. 1 decimeter is what? 10 raised to the power minus 1 what? Meter. I now ask a technical question, some question that only someone that thinks can answer. I ask, but it's simple, but you need to think. I ask question. I now ask, if 1 decimeter is 10 raised to the power minus 1 meter, how many decimeter can we find in 1 meters? That's the question. Which she answered. She said what? 10 decimeter make 1 what? Meter. In fact, if you turn that to your exercise book now, it may be there. Is it there? Metric system, is it there? Is it there? So how many decimeter make 1 meter?
Okay, 1 meter.
How many decimeter make 1 meter?
Okay, 10 decimeter make
Look at this here now. 10 what? Decimeter make what? 1 meter. Because if you divide 1 decimeter actually is 0.1 meter. If you divide both sides by 0.1, here becomes what? 1 meter. Here becomes what? 10 what? 1 divided by 0.1 is what? 10 decimeter. 1 decimeter divided by 0.1 is what? 10 decimeter. So 10 decimeter is equal to what? 1 meter. Is it clear? Is it clear? What is this?
I'm going to say 1 meter times 10 decimeter. How did that divide come in?
No, now we are doing something else. This is, we are just this is just conversion. What are you doing with a calculator? Keep it there. You're not serious. You are punching calculator. You cannot divide 1 by 0.1. You are punching calculator. And you want to right jump. Don't spoil yourself with that thing. Keep that in my side. Look at it. 1 divided by 0.1 is what? 10.
1 divided by
We got, didn't we get, listen carefully. Maybe we got that 1 decimeter DM is equal to what? 10 raised to the power minus 1 what? Meter. Move 10 raised to the power minus 1 from index form to ordinary form is what?
Okay, 1 divided by 10.
Is what?
1 over 10.
Which is what? 0.1. It's not 0.1. Or even if you leave it at 1 over 10, fine, it's okay. Now, but this is 1 decimeter. It's 10 raised to the power minus 1 what? Meter. I now ask a question. How many decimeter will be in 1 meter? How will you make 1 meter such? What will you do to this 10 raised to the power minus 1 meter to get 1 meter?
Okay, I will do this thing. I will put it in decimal form. Then make this thing a place where I will put 1. That is what
Look at this thing now. Look at from here now. What can you do to this side? Remember the question I ask is how many decimeter make what? 1 meter. 1 decimeter makes 10 raised to the power minus 1 what? Meter. 1 decimeter makes what? 10 raised to the power minus 1 what? Meter. Now, how many decimeter can we find in 1 meter? How will you do it? Make this side to be 1 meter. Area. Now, what do you do? What do you do to this? What do you do to make this side 1 meter? Look at this board. What do you do to here to make your simply divide with the same coefficient now? Area. And this will send what? 10 to the power minus 1. 10 to the power 1 cancel 10 to the power 1. You will get what? 1 meter. Area. Then 1 meter, 1 divided by 10 to the power minus 1 is what?
1 divided by 10 to the power minus 1.
You don't know. Calculate megu na. Hey, calculate. On you go ni paku. Now look at it now. You are the one that said 1 over 10. Is it not true? You said now saying 1 over 10. What's the answer? 10. Emazinka. You confused me. So bad. 10 dm is what? 1 watt meter. That's why in that your book you see 10 decimeter make 1 watt meter. No problem. We'll keep strongly. This is mathematics, hope you know. Mathematics yeah, mathematics. You know mathematics? Standard for you know standard for okay. Don't worry. You see it now. Any question here? Any question? Now so we have agreed. We have done what now? What have we agreed on? We have agreed that what? That 1 decimeter is what? 10 to the power minus 1 watt meter. Are we together? Now let's look at centimeter. Look at this centimeter now. Centimeter. So let's do the centimeter for centimeter. So 1 centi. What is the centi? Is a prefix. What is the value of centi? What is the numerical value of centi? 0.01. Do you people agree? Do you agree? Say yes. Stop. I don't like people know the head from me. Say what? Yes. And say it, because if you speak it out with your mouth, it does a lot of things. Don't be doing like this. Say it with your mouth. Is what? Which is certain as put it in index form. Is what? Monotone, right? Good. So now bring centi and bring meter and put together. It becomes what? It becomes what? Centimeter. Bring centi and meter together. It becomes what? Give me what is index form to tell us. But what is index form? Index form is power now. Put it as power. This thing we have been doing here since. Get it. What is this 10 to the 3 means what? What is 10 to the 3? No, forget this one. In mathematics, 10 to the 3 means what? 1. How many zeros? So this is the index form. Power form. You can call it index form or power form. Or exponential form. It's okay. Anyone is okay. Multiple, where submultiple.
Okay, multiple, those ones they belong minus
good.
Already from 3 to 0 or 1 to 0.
Well, the other ones above it too. I just point at this one.
Already for this straight that
Yes. Before 0. 0 is not inclusive. Okay, because it's not inclusive.
Then that's submultiple. 0 is excluded.
Yeah, minus below. From minus 1 down. They are submultiples. Now, I said that centi If you get centi and get meter, it becomes what? Centi what? Meter, right? So that means now multiply the value of centi, the numerical value of centi by 1 meter. You get what? 3 raised to power minus what? 2 what? Meter. That means that 1 centimeter is what? That means that 1 centimeter is what? 1 centimeter is what? Minus 2 what? Meter. That means 1 cm. Remember their symbols, so that means 1 cm is what? 3 raised to power minus 2 what? Meter. Is it clear? So if 1 cm is 3 raised to power minus 2 meter, how many cm are in 1 meter? If 1 cm, do you agree with me that 1 cm is 3 raised to power minus 2 meter? Now, if 1 cm is equal to 3 raised to power minus 2 meter, how many cm are in 1 meter?
It's also equals, 1 cm also equals to that 3 raised to power minus 2.
If 1 cm is equal to 3 raised to power minus 2 meters, how many cm are in 1 meter? No, if 1 cm is equal to 3 raised to power minus 2 meters, how many cm are in 1 meter? Is what?
10.
How do you get 10? Tell us how you got 10. No, just tell us how you got 10. So let me know where you got 10 from, so we can, if there's any correction, we'll make it at once. Just say where you got, how you got 10.
So I divided this 10.
What?
I divide that 10 raised to power minus
2.
2.
By what?
By that coefficient of that meter. Then I divided those 7 since it's the same one.
With what?
1 cm is equals to 10 meter. So it will be how many cm are?
No, the question is this: 1 cm is 3 raised to power 2 meters. You know how you got this one, right? And I asked you to tell me how many cm are in 10 meter and are in 1 meter.
How many cm that are in 1 meter? So I divided both sides.
By what?
By this 10.
E or 10?
10 raised to power minus 2.
So, and got to what?
So
No, just be telling me what to do.
this one, okay, divided by 10 raised to power minus 2. The other one divided by 10 raised to power minus 2. So this now give me 1, 1.
Nke a 1. Nke a nko.
So it is 1 over 1, 2, 1 no name. Anyway, so okay, I made a mistake.
So what's the answer?
So it's if you do 10, 1 over 2 over 10.
2 from where?
That 2 then we inverse from there.
No. 2 from where? This 10 from minus 2 means what? Put it in ordinary form. What is the value? What is 3 raised to power minus 2 in ordinary form?
2 over 10.
That's your problem. That's where you should get from. How can you say that 3 raised to power minus 2 is 2 over 10?
Okay, what was 0.001?
So put it in 0.001. Put it in your fraction form. You're doing now. It becomes what?
1 over 1. No. 10 over 10,000. No, 10 over 100.
What are you even saying?
Oh. So, okay, you're one. Okay. 0.01. 1 over 100.
Good. Now 1 over 100 here. So you got 1 over what?
100.
Over what? So what's the answer?
100.
So where do you get 10 from before? So that means 100 centimeter is what? Is what? 1 what? 1 meter. So there are 100 centimeters in what? 1 meter. Now the basic thing is to understand this thing that we have 1 centimeter is taken as saying 3 raised to power minus 2 what? Meter. Are we together? Now let's go to what? Millimeter. Milli is the value of milli is what? 3 raised to power minus what? Minus what? Minus what? 3. Good. Now bring milli and meter together. You form what? Millimeter. So what it means is that multiplies 3 raised to power 3 minus 3 by 1 meter. You get what? 3 raised to power what? 3 watts. Thank you. Minus 3 watts meter. That means 1 centimeter. Sorry, 1 millimeter, right? Is equal to what? Minus 3 watts meter. Is it clear? Now, if 1 millimeter is 3 raised to power minus 3 meters, so tell me, it's even from the name itself, milli, 3 raised to power minus 3 meter. Come together, it becomes what? 3 raised to power minus 3 watts. This 3 raised to power minus 3 belongs to what? Milli. 1 meter belongs to what? The base. It's not true. So milli means 3 raised to power minus. If you know that milli is 3 raised to power minus 3, it's simple. If they ask you convert millimeter to meter, imagine a milli mean, you should know the meaning of this unit, this prefixes. Imagine a milli means what? Milli means what? 3 raised to power minus 3. Just use it to multiply the base by one base unit, 1 meter. You get your what? Millimeter. So that means 1 millimeter means what? 3 raised to power minus 3 times 1 meter, which is 3 raised to power minus 3 what? Meter. So if 1 millimeter is 10 raised to power minus 3 meter. Can you question na film that simple question I think two of you have got also now look at it. 1 millimeter. If 1 millimeter is 10 raised to power minus 3 meter. Now how many millimeter can we have in 1 meter? Good. And now, wait, what are we with 3 raised to power minus 3 and 1? Hey, you know, okay? Okay, by 1,000 fold. Yeah, 1,000 fold.
So if 1 millimeter is equal to 10, how many millimeter are there in this? 1 millimeter over this. Within this shape of meter in the divided this side. So here I know 1. So here we have 1 over 10 raised to 10 raised to power minus 3. So this 10 raised to power minus 3 in normal form of 0.001. Then t and this fractional form 0.0001. 1 over 1,000. So it's 1,000.
1,000. Good. So everything is now what? So that means 1,000 watts. 1,000 watts. Saying what? What do you say? Is what? 1,000 what? Talk, let me understand what I'm saying now. 1,000 what? Is what? That's where you made mistake. You are saying 1,000 meter is wrong. It's 1,000 millimeter that form 1 meter. But if we are saying 1,000 meter, that's why I say it's wrong. Wait. Chine, your 1,000 is what? Which unit has that 1,000? Is that what you did before?
I just said I didn't say 1,000.
And what could you calculate? But you have you not realized the mistake you are making? You are telling me 1,000 meter. That's why I say it's wrong. It's 1,000 millimeter, because from this thing now, if 1 millimeter is 3 raised to the power minus 3 meter, divide both sides by what? 3 raised to the power what? Minus 3. Are we together? This will do what? Cancel this one. What you have here is what? 3 raised to the power what? Minus 3 what? Which is something as saying what? 1 over what? 1 over what? 3 raised to the power what? 3 of us. So this one do what? Come up, right? It becomes what? 3 raised to the power what? 3 meter. Which is what? 1,000 what? Meter. So 1,000 meter make 1 what? 1,000 millimeter, sorry. Make 1 what? Meter. Check your book. Check your book. How many 1,000 millimeter? Or the water, is it up to 1,000 there? Is it up to 1,000 millimeter make 1 meter?
1,000 millimeters.
Check millimeter.
Oh, 10 millimeter make 1 centimeter.
Is there 1,000 millimeter there?
Yeah, I have 1,000 meters equals 1 kilometer.
We have done that one now. Here. When we say 1,000 meter is 1 kilometer. It's not true. Because 1 kilo is what? 3 raised to the power what? 3. 3 of us. Oh yeah. We have done that one. I'm asking, is there anything like 1,000 millimeter there? Okay, maybe from you can do. You know, they will not write everything for you. They write the major thing. You can, from your own calculation, you can get what? Others. So, what?
Normally, this is so this if 1 millimeter is equal to 10 raised to the power 3, how many meters are there in 1 millimeter?
No. Yes, the same thing. But be careful of the signs. Yes. Okay, so you can come and carry. But be careful of the signs, okay? Be careful of the sign. Where you have minus, be careful of it so you don't make mistakes. Oh, it's not time. But it's okay, Sha. It's okay. It's okay. You learn it once and for all. I believe that now, if you see conversion now, you can do it easily, right? Good. We have, okay, this is for what? Learn to. When you come to what? Mass. Let's look at mass. Let's look at mass, okay? Let's look at mass. Let's look at under base units. The base unit we look at now is mass. The base unit we look at now is what? Let's look at the base unit of mass. I told you it's what? So gram should be where? Here, right? 3 of us. Gram should be where? Here, at the middle, right? Now, if gram should be at the middle, let's look at the multiples. Let's look at deca. Deca, bring deca and gram together. You will form what? You form what? Deca what? Gram. Then multiply the prefix with 1 gram. You have what? 3 raised to the power what? 1 what? Gram. Is it clear? Is it clear? It's the same thing we are doing here. Don't waste your time. It's same thing here. Just get that prefix and multiply. Awesome, man. This is what I'm doing here. What happened today? Are you sure?
Yes, sir.
You look so distracted. Okay? What is it? So why didn't you tell me on time? You are sleeping. So you know you have less to tell. Why did you go back to the hostel? No. The wisdom demands that you just hang around, stay around. We just be eating somewhere. 4 p.m. we enter class. Don't go to hostel. If you go to hostel, you do other things and sleep off. You come here late. Hang around. Just hang around. Higher 6 p.m. Let's will be over. You can go to hostel and sleep. Maybe wake up around 8 or 9. You can now come to class to study. Not after school. You go to hostel. A lot of things will take place there. You will start this. You will end up not coming out. So please, if you know you have 4 p.m., why go to the hostel? Stay somewhere and read a book. Enter the library and read a book. Anywhere here, you can stay and read a book. Now I say we are working on what gram now? Mass. We are done with what length? We are working on mass. Mass is a quantity. True of us is a fundamental what? Quantity. Now we have placed gram here. We say that the gram is the base unit. We have placed it here at the middle. That 3.0 belongs to the base what? Unit. We have placed it here. Now because do you know why I say that it belongs to the base unit? Then multiply 3.-1, 0 times gram. Here is what? 1. True of us. 1 times gram is what? Gram. So the base unit is what? Gram. Now let's go up to deca. Deca, bring deca and gram together. You have what? Deca what? Gram. And the value of deca is what? 3.1, right? Then multiply 3.1 by what? 1 gram. You get what? 3.1 what? Gram. Now let's go to hectogram. Hecto is 3.2, right? Now bring hecto and gram together. You form what? Hecto what? You form what? Hectogram. You form hectogram. Now if you form hectogram, hectogram. Now use 3.2. Hecto means 3.2, right? Use it to multiply 1 gram. You get what? 3.2 what? Gram. Are we together? Good. Now let's go up to kilo. Kilo is what? 3.3. Are we together? Now if kilo is 3.3, bring kilo and gram together. You form what? Kilo what? Gram. Remember the value of kilo is what? 3.3. Multiply 3.3 by 1 gram. You get what? 3.3 what? Gram. So kilogram is what? 3.3 gram. Let's look at it. Here, this means that 1 kilogram, 1 kg, right, is equal to what? 3 gram, which is what? 1,000 what? Check your book. How many kilogram? Check how many kilogram that is 1,000 gram. How many kilogram that is? How many gram are 1 kilogram? How many? 1,000 gram is what? See it now. 1,000 gram is what? 1 kilogram. Is it clear? Now let's look at submultiples. Let's go to what? Submultiples. The first submultiple here is what? Deci, right? So deci, bring deci and gram together. You form what? Decigram. You form what? Deci what? Gram. Remember the value of deci. Deci is 3.1. So that means multiply 3.1 by 1 gram. You get what? 3.1 what? Gram. So 1 decigram is 3.1 what? Gram. Let's look at another one. Centi. Centi is what? 3.2. Bring centi and gram together. You form what? Centigram. You form what? Centi what? Gram. Now multiply the value of centi by 1 gram. It becomes what? 3.2 times 1 gram is what? 3.2 what? Gram. Now next one is what? Milli. The value of milli is what? 3.3. Bring milli and gram together. You form what? Milligram. You form what? Milli what? Gram. Now multiply the value of milli, which is 3.3 by 1 gram. You form what? 3.3 what? Gram. That means that 1 milligram, 1 mg is equal to what? 3.3 what? Gram. So now, if 1 milligram, if 1 milligram is 3.3 gram, how many milligram are 1 gram? 1,000. Are you sure? Is what? Look at it now. Here, if 1 milligram is in 10 square minus 3 gram, you want to know how many milligram that we can find in 1 gram. Divide both sides by what? 3 square minus 3. Here by what? This will divide this. You have what? 1 gram here. This 1 milligram over, this certain are saying 1 milligram over what? 1 over 10 square what? 3. True or false? This will not come up. It becomes what? 3 square what? 3 what? Milligram is equal to what? 1 gram. Are we together? So the 3 square 3 is what? 1,000 milligrams. So there are 1,000 milligrams in what? 1 gram. Check your book again. Check how many milligrams in 1 gram. One milligram in 1 gram. 30 kwa?
Okay, that's 10 milligram. One, it's not milligram.
In 1 gram, yeah.
From here. Milligram, yeah.
Okay, they didn't include they didn't.
Yeah, I want to write down like I need to space.
Which question?
Okay, but like say if 1 milligram is equal to 10 raised to power minus 3 gram, how many?
How many milligram are in 1 gram? Are in 1 gram. Is it clear? Are you sure? Is it clear, Izu? Are you sure? Good. Children, is it clear? Good. We have checked this thing holds in any unit to any what? Unit. Be it power, be it whatever, be it watts, any unit, be it joules. You have you in joule is energy, right? Or work done. You can have kilojoule, kg. Have you heard of kg before? Kg. Kilojoule of power of energy. Kg now, this whole thing came from this thing. Different units came from it. Kilowatt is also, kilowatt means what? 3 square 3 watt. In kilowatt, what is the base unit in watt? In kilowatt. It's not watt. Kilo is a prefix added to what? Watt. So 1 kilowatt is how many watts? Good.
This thing is now how many milligram in 1 gram. So this 1,000 you need to
1,000.
that 1,000 you need to
What are look at the question. You get the unit for the question you ask.
So how many milligrams? So yeah, that 1,000 milligrams.
Yeah, now. 1,000 milligram will be 1 gram. So you have kg, kilojoule. You have another one mega. I'll give an assignment to you. You go and research on others. I want you to follow this number to it. I'll give you from 3 square 4 up, maybe to 12. From 3 square minus 4 down. You find it. Find out the name of these prefixes. Find out find out the name of these prefixes. Write it down. Find the name of these prefixes. Sorry. I'll just give you the numerical value. You find their name. Then use them to form different units. Are we together? The question is this. Find the name of the following prefixes. Find the name of the following premises and use them to form different units with the following base units. I'll list the base units you will find it them for. Where that's all. Find the what? Name of the word, the following words, prefixes. To form different units with the following base units. That is when I say I mean multiples and what? Multiples and what? So multiple units. Okay, simply you can put it this way. Can make more sense. Let me know where I'll start. Find out the name of the following prefixes. And use them to form different good food. Units. And use them to form multiple units and the sub multiple units with the following base units. Good. We stopped at 3 square 3, right? I want you to find 3 raised to the power 4. 3 raised to the power 4. Find 3 raised to the power 6. 3 raised to the power 9. 3 raised to the power 12. 3 raised to the power 12. 3 raised to the power minus 6. 3 raised to the power minus 9. 3 raised to the power minus 12. Find them. 3 raised to the power 4, 6, 10, 12. Minus 6, minus 9, minus 12. This is a prefixes. Find their name. The same way here, the same way 3 raised to the power 3 is what? Kilo. 3 raised to the power 12 has a name. Find out. The same way 3 raised to the power minus 1 is deci. 3 raised to the power minus 6 has a name. Find out. Then you now use them to form mega submultiples and multiples with the following base units. With the following base units. What base unit? What that I say? You say what? Sorry. Uh-huh.
Then it's your time here, 10 raised to the power 12.
Uh-huh.
Then it adds the base unit.
To base unit. The base unit can be meter is a base unit now.
Same base unit you want.
I'll give it the one I want you use, okay? We have worked on length, which is what? The base unit of length is what? Meter. The base unit of mass is what? Gram. Now, work on the following base units. The base unit of time is what? Is what? So check for what? Seconds. Okay? Is it clear? Check for what? Seconds. Seconds is the base unit of time. Then check for watts. Watts. Measure for watts. Measure for seconds. Then do it for watt seconds. Watt. Also do it for joule. Yes. Joule. Seconds is S. Watt is W. Joule is what? J. Immediately you write the same below, okay? That means if, let me give an instance. If J is a symbol for joule, and the base unit is what? And the kilojoule will now become what? Kilowatt joule, which is what? K what? J. You also write the value, right? Which is what? 3 watt joule. Is it clear? So 1 kilojoule. 1 kg J is what? 3 raised to the power what? 3 watt. Is it clear? These are the things I want you to do. I want to test your understanding of what we'll be doing here since. Now, let's work with this form. Then what you do for me is this. When you write it, mention the name, the quantity that has this unit. Which quantity has seconds? Which quantity has what? Power. Which quantity has joule? Work or energy? Which quantity has okay? Let me add another one. Ampere. Good. Do it for seconds. Watts. Ampere is A, right? Do it for seconds. Watts. Joule. Ampere. Is it another units? I'll add. See how he's looking at me. Volts, yes, volts. Do it for what? Seconds. What? Volt is V, right? Up here. Do it for seconds. Watts, joule, ampere, volt. Volt is what quantity has volt as they are listed. Good. Potential difference. Good. I like that. I think let's stop here. Do for these 5 units. If you do finish that, I believe anytime you hear any particular thing, you'll be able to say one or two things about it. When you want to submit it. Hey. Okay, don't worry. See what I will. It seems I'll write timetable here so that what we're doing is this. I see we'll be doing this. It seems because you don't know exactly what the timetable is. I'll give timetable. Then I'll tell you how to go about this. Now I'll give another. After this class, now I'll write the timetable for the two centers, for this center and the other center. Okay? Is it clear? Are you okay now? Good. It's too much. Okay, you don't want to study. You don't want to study. Then I'll stop assignment now, and I'll teach you and go my way. Do you prefer it? Eh? Do you prefer to teach you without assignment? Eh? Please, it's to help you to study. If I don't give the assignment now, there are a lot of things by the assignment you've done for these past few days, there are a lot of things you've learned from them. Which if I were just teaching and you go, you just somebody to open their book to read. But this assignment will lure you to go and open your book and do it, because if you don't do it, if you come here, I'll mess you up here. So you be forced to go and do the assignment, and by the time you do the assignment, you are reading. So I know what I'm doing. Your own is to do what? Follow the lead. Simple. Do what I asked to do. At the end, you thank God that you did. By the time, if you don't understand, by the time you come here, I call you out 5 times, 3 times, you don't know what to say. Shame will become your second name. We go home and do what? Study. That's the brain behind what you are doing here. It's not just to teach you go. I don't teach like that. And I always make this point. I don't need crowd. I need people that are what? Dedicated. I don't need their money. Because if money is what I want, yes, money is important, but it's not the main thing. If it's what is pushing me, I'll bring down my standard. Anyhow you do it, you go. But most people don't like going to where there is standard. They want where they go, come and do anything and go their way. And there's things you do yourself, I'll just count your money and give you, tell you to stop coming. You are aware, right? Yeah. Ask him. I have done it to several people. Once I know they're not serious, I call you, count your money, take your money and go. I don't need their money. I want people that are dedicated. I want to. Most of the people I taught are in school now. At least, if not for the course they want, at least they are in school. You cannot stay at home. It's not possible. So the point I'm making is this: please take it seriously. Don't tell me they're not like assignment is too much. Anyway, I take it as if maybe we are joking, sha. But go and do this. It's simple. Just do it. By the time you do this assignment, you have a better understanding of what you have been saying. And please, in our next physics class, you come out here and explain what you did. You're not submitting anything to me. Of course, you know now. You come out here and explain what you did. Are we together? Good. I think we have actually talked about these units. In our next physics class, this took our time, but at least if you can understand this, it will help you a lot in your conversion. Most people run away from conversion because of what? They don't understand this. Hello? I'm trying to help you to start understanding conversions. You don't to cram it. You don't to cram 1,000 milligram. You make mistakes. Eh? Convert to what? Convert what? If you wish, all I need is that you come here. Anything extra you want to do. If you come here, I will hear what you did. Simple. Anything extra you want to do to show that you understood it, I will appreciate that. If you make a mistake, I'll correct you. Okay? Just open your heart. Do whatever you think. Anything you can do to prove to me that you understood what we did today. That's the idea. That's why I gave you all these things. So there's no but the point is that I'm here. If you make mistake, I'll do what? Correct you. Simple. But the worst part of it is that you not do anything. That one is annoying, and I won't tolerate it from anybody. If you did it and make mistake, see, if you do something and make mistake, and you are corrected, you learn nothing more. You are better than someone that did not do it. Are you aware? You are far, far better Don't say this one I'm doing. I'm sure I'm getting it. Won't they laugh at me? No problem. Bring that nonsense you did. By the time you talk that nonsense, from that nonsense you are talking, sense will do what? Come out. But if you did not do it at all, that one is the worst. Or maybe you are in the caliber of those that because they did not do the assignment, they run away, they will not come for lesson that day. You are dealing with yourself. You are not doing anybody. You are dealing because what would do that day, you miss it. It's not true. What you do that day, you will miss it. You will miss it. What you would have learned in that assignment, you also do what? Miss it. And if you keep missing lessons, miss like 1 month, I'll call your parent and tell them that I don't want to see you here again. Stop coming. Because it's of this money you are giving me, I'm tired of eating it. Because I'm not teaching, you're not getting anything for the money you are paying me every month. Because your child is not coming for lesson. So no need paying me money without your child coming here. Am I correct? So please take what we are doing here seriously. As I said before now, in next class, we start from where? We'll now go deeply into what measurement proper. We'll start looking at different measurement of different quantities. We check how to measure length and the apparatus and used to measure length. We check different use of calipers, vernier calipers, micrometer, screw gauge, and how to read them. We check all those things. We treat how to read them. We also go to volume, how to measure volume. Different way of measuring volume. Volume for what? Regular, irregular, solid. How to measure liquid volume for what? Liquid. After that, we now go into this thing again. We also go into weights, how to take weights using balances and other thing. Then we now close. I mentioned dimension before because I wanted to explain something. We now use dimension to close the chapter on what measurement and what units. This is what we do by God's grace in our next class. Had it been you people, have you seen how this took my time today? Because you people don't understand it, so I had to take time to explain it. I believe that if I give you conversion, something to convert tomorrow, you won't tell me long story. That's what I did. Not tomorrow again. I wanted to talk about maybe we are checking weight, or maybe what we are doing in our second center. By the time we start entering into energy now and power, one human being will start asking me, sir, how many kilograms will you find it? Man, that person is not serious. The idea of this thing now is for you to know how to do the conversion. By the time you finish this thing of jewel, now you know exactly how many jewel should be in 1 kilojoule. If you do it well, you get a mega jewel. There's mega jewel. There's pico. You get a pico jewel. You know how many like megawatts. You know how many watts you find in what? Mega is a prefix. I won't tell you which of this is mega. Hello, I won't tell you which of this is what? Mega. But just know that mega is a what? Prefix. Pico is a prefix. Nano is a prefix. I won't tell you which is which. Go and do it. And come to class. Let's discuss it. Okay? At least you must have seen nanometer, all those things before. That's where they got all these things from. So if you understand this, you will enjoy it. There's no unit you will see. You will not know how to convert it. It's not possible. You don't even need to punch calculator. If I see calculator again, if I see calculator again, I'll deal with you. If I see calculator again, 0.1, you punch calculator for me. 1.0, I put you calculator. That's wrong. Please train yourself, okay? So you don't. There are some things you do. Yes, there's area you get to use calculator. I understand that one perfectly. When you get to issues, you need calculator. It means I'll tell you punch your what calculator. But there are some things I will see. If I see you can't calculator, I'll be like, what is this one doing? Simple thing you can just look at and get the answer. You're punching calculator. No, that's too bad. All right, so that's where we'll stop. I'll give assignment. Okay, I have given you assignment already, but that assignment is small. I'll give you the one from this one is just assignment that just came up from the lecture. I will not give you the one from past question. That's every day you must solve assignment from where? Past question. It's a must. The number depending. If the one I gave you from if the one that came off from the lecture is more, I may reduce the one for past question, but there must be past question what? Assignment. But if there's none at all for the day, I may give up to maybe 10 in past question. But every day there must be assignment on past question. We'll review in our next class before the lecture proper. If this one is tired of assignment, it will go. You have not started the assignment. By the time you record all this assignment and do it in your book, give yourself 1 year. By the time you look at it, you say, thank God I did this thing. You'll be happy you did it. Now let's see what we have there. Now pull down this. Even though okay. See what happened here now. Okay, put down this. Let me go to where we have covered very well. Put down this assignment. Put this in down. Which of the following is not a fundamental SI unit? Which of the following is not a fundamental SI unit? Which of the following is not a fundamental SI unit? A. Meter. B. Ampere. C. Kelvin. D. Radian. R-A-D-I-A-N. Radian. Number 2. Which of the following is a derived unit? Which of the following is a derived unit? A. Kilogram. B. Meter. C. Kelvin. D. Newton. Number 3. Which of the following is a fundamental unit? Which of the following is a fundamental unit? A. Newton. B. Watt. C. Joule. D. Second. Number where? Number what? Number 4, right? Okay, we'll start from number 4. Good. I'm coming. Let me look for another question. I'm coming. The internationally agreed system of units in bracket SI. The internationally agreed system of units in bracket SI, bracket close, for physical measurements are Let me write it out. Look up here. Look up here. Option A. Option A is this one is pound, LB, feet, FT, seconds. Then option B is gram, small g, meter, M, then second, sec. C is kilogram, meter, can you see the board? Sec. Then D is centimeter, gram, sec. The internationally agreed system of units SI for physical quantities are, then you list the thing. The correct units, the number what? Number what? 5. Okay, we are entering number 5. Number 5. Kilogram, comma, meter, comma, sec, seconds. Then, question number 5 says, question number 5 says, where are we now? 5, Shay? 5 says, the correct unit of energy. The correct unit of energy. The correct unit of energy is A. Kilogram per meter cube per second squared. Look at it. Kilogram per meter cube per what? Second what? Squared. B says kilogram per meter per second squared. B says kilogram per meter per second squared. Kilogram per meter per second squared. C says kilogram meter cube per second squared. Kilogram meter cube per second squared. D says kilogram meter squared per second squared. Kilogram meter squared per second squared. That's question number what? 5. Good. In our last class, we mentioned one or two things about what? Dimension. At least I know that we understood what I thought in dimension, right? So I want to give you a question there, so we can appreciate what we did in the last class. That will be the question number what? 6. Question 6 says, the physical quantity that has the same dimension as impulse. You first of all research what is impulse and the dimension for impulse before you can answer this question. The physical quantity that has the same dimensions as impulse is A. Energy. B. Momentum. C. surface tension. C, surface tension. Surface tension. D, pressure. D, pressure. Question number what is that? 6. Number 7. The dimensions, you write this. The dimensions ML in capitals squared T what? Squared. This dimension, the dimensions, you write this. The dimensions, you write this. Represents A. Represents A. Option A. Momentum. Momentum. B. Option B. Power. Option B. Power. Option C. Work. Work. Option D. Pressure. Option D. Pressure. Option D. Pressure. Which of the full number 8 of here? Right? Number 8. Which of the following quantities? Which of the following quantities has the same unit as the watts? Watts. Which of the following quantities has the same unit as watts? As the watts. You know what now? Which of the following quantities has the same unit as watts? Option A. Force times times. See how you write it. Force times what? Write it out in word. That's how the question came. Force times what? Time. Option A. Force times what? Time. Option B. Force times distance. Option B. Force times distance. Option B. Force times distance. Option C. Force times acceleration. Force times what? Acceleration. Option D. Force times velocity. Force times what? Velocity. Force times what? Velocity. Force times what? Velocity. Now, question 9. Question 9. Which of the following units? Which of the following units is equivalent to kilogram meter per second? Kilogram meter per second. Look at it here. Which of the following units is equivalent to kilogram meter per second? Which of the following units is equivalent to kilogram meter per second? Option A. Newtons per second. Newton per second. That second should use small letter. Newton per second. Newton per second. Per second. B. Newton meter per second. B. Newton meter per second. C. Newton seconds. C. Newton seconds. J. Joule per second. J. Joule per seconds. Joule per second. Question number 10. The last question for the assignments. Which of the following is dimension of pressure? Which of the following is the dimension of pressure? Which, can I click this one? Which of the following is the dimension of what? Pressure. Which of the following is the dimension of what? Pressure. A. M, all in capital. M per L per T squared. M per L per T squared. B M L per T squared. M L per T squared. C M L squared per T cube. M L squared per T cube. D M per L cube. D M per L cube. M per L cube. So this assignment, you do it, two of them, and you do it inside your notes. Make sure you understand them. Do it inside your notes. Then in our next physics class, we normally do our review of our assignments. Once you come here, we do review of our assignments before we go to the topic we have for the day. And our review is that if I point to you, you come out here, tell us what you did. If there's an error in what you did, I'll ask you, number one, you explain what you did, you answer. Like this answer that this OBJ, the way we answer our OBJ is this OBJ. I'm just saying it for you that just joined us today. Our OBJ is that you don't come and go to past question or go online and Google and saw the answer online and come and tell me A. You will stand here, tell me if the answer is A, you tell me why it's A. If it's not, if it say it's not B, you tell me why it's not B. As you have these options here now, you should be able to know if this is the answer. If it's not the answer, you tell me why this is not what? The answer. If this is not the answer, so you have to analyze all the what? Options and be able to say why they are not the what? Answer. Then the one you picked at the answer, you explain why is the answer. That means you know that question, you know it. That's how we do for all the 10 questions. If I point you, come here and do it. Then if at the end of the road, if we agree with you, if we don't agree with you, if nobody knows it here, I'll answer it. That's how we do it until we finish the whole what? Questions. Then the other one, the same way, if I call you, explain. So this is how we do our assignment. Then if there's any correction, you make as we are giving the correct answer, you are making the correction in your note immediately. So you don't go and read what you did and thinking that is the answer. Am I communicating? That's what we do, an assignment. So the review will be in our next class, in our next physics class. As I said, after this class, I'll write out the timetable for this. We have 2 centers. The first center is here. Second center is the other side. So, don't worry. If you're interested in joining second center, it's the same money. You're not collecting extra money from you. But the one thing there is that it's not the same. Like here, as we are teaching here now, if you come back here next week, the next physics class in this center will continue from here. In that center, we are doing another topic in physics. So if you have the strength to be coming here and be coming here, wonderful. No, it's okay. But if you don't have the strength, if it's here you want to focus on, it's okay. But the point is that the person coming here and coming here is covering more topics at the same time. There, I think we are where we serve there. We are in work, energy, and power there. Something like that. In chemistry, we are in another topic there. The idea is that they run parallel because some people may want to be focused there and becoming this he lives there, but he after going there, he still comes here. But it's okay. You will not be charged extra. So it's your choice. So for here now, in our next physics class here, I will write a timetable for the both centers so that I want all this while I don't think I've given the timetable before, so that you know exactly what you expect. Especially now that I can see that this issue of the reviewing all the assignments in the before class, I know that it takes you for time, right? So I will go back to the initial arrangement before. This physics assignment will be reviewed in our next physics class. Is it okay like that? See his face. Is it okay like that? So, but do you know why I stopped that thing? I noticed that some of you will go, you not do it. Some of you will go and package that assignment and leave it like that. Some even forget that they give assignment. They'll come and say, hey, assignment. But if you review the next day, you know that you'll be forced to do what? Go and do it at home. So let me just give that belief for that. Let me just allow you people. If I come here next time we have physics, I notice that if anybody doesn't do that assignment, then I will know what to do. So now I don't know if there's any other question. This announcement was just because of me, because you just joined us, so you don't get lost. Please, 4 p.m. We have to review this assignment before we do the class. If you come late, my target is that this lesson should hold from 4 p.m. to 6 p.m. dot. Everybody will go. But if you come by 4:30, you'll be dragging us, because I should cover the 2 hours so we can review the assignment and do the topic of the day. But if you don't come on time, how do we achieve that? Please, let's make it on time. Once it's 4 p.m., we'll start so we can cover. At least if you use 30 minutes to review the assignment, at least 1 hour 30 minutes will be for lecture. And after the lecture again, I'll give assignment for the next class. So please, let's take it seriously and make it a point of duty to come on time. All right, thank you very much for your attention. Please study, okay? Apart from assignment, I want you to develop study habits. The way to do assignment is this. Go to textbook where the topic, every assignment is coming from a topic. Go to textbook where that topic is. Read that topic in that textbook first. Try to understand the topic in that textbook. At least go through it. Then you can now do the assignment. You can browse online, get other information to do the assignment. But make sure you go through that topic in a textbook. It's important. So you not be floating. And now any word you see, try to find the meaning of that word. You can't say you are doing an assignment. You see a word, you don't even bother to know what that word means. And you say you are doing an assignment. Only here, man, you are doing nothing. All right. See you next time.